I'm Davinia, and I am going to introduce about the atoms, molecules, and the ions. In this video, we will learn about the definition and its examples. First of all, we will discuss about the atoms. An atom is any particle of matter and its most basic label, which contains at least one protein. An atom is a tiny individual particle of an element. It has 180 different kinds of atoms in the periodic table. What is the three atoms? We know that atoms are made up of three particles, the neutrons, electrons, and protons, which are they compose even smaller particles such as the quarks. What is considered an atom? An atom is a basic unit of an element. An atom is a form of matter which can be further broken down using a chemical means. The examples of the atom are oxygen, hydrogen, sodium, uranium, and the fluorine. The second one is the molecule. What is the molecule? A molecule is a neutral group or more atoms held together by a chemical bond. An atom in a module are held together by covalent bond. Both atoms and molecules are neutrons. The example of molecules are the water, table salt, calcium oxide, carbon dioxide, and the glucose. The third one is the ion. An ion is a charged subatomic particle such as free electron ion. Ion is an atom or group of atoms which the number of electrons is not equal to the number of protons. Ion is the smallest particle of the substance. It has all the physical chemical properties in the substance. It is made up of one or more atoms. An atom is formed when an atom or molecule get together or uses electrons. It can also be polyatomic and monatomic charge. It means the negative and the positive charge. The example of the ion is the sodium, potassium, calcium, and the fluoride. Hope you enjoy and learn a lot in this discussion. Bye-bye!
Hi everyone, I am Zakia Minbias and we're going to talk about the atomic theory of John Dalton. At the beginning of the 19th century, the English scientist John Dalton proposed a theory called the atomic theory, and this became the basis of the study of chemistry. There are 5 main proportions of this study. First is that all matter is comprised of tiny, definite particles called atoms. He hypothesized that the law of the conservation of mass and the law of the definite proportion could be explained using the idea of the atoms. He proposed that all matter is made of tiny, indivisible particles called atoms, which he imagined as solid, massy, hard, impenetrable, movable particles. Now, it is important to remind ourselves and to take note that since Dalton did not have the necessary instrument during that time for his study or for his theory, he wasn't able to see or otherwise experiment at the individual atoms since it's just 19th century at that time. He did not have any insights into whether they might have any internal structures. And we might visualize Dalton's atom as piece of a molecular modeling kit, where different elements are spheres of different sizes and colors, while this is a handy model of some applications today because we're able to know that atoms are far from being solid spheres. And second from that main proportion is that atoms are indivisible and indestructible, which I think have been proven false. Third is that all atoms of a particular element share identical properties including weight. Dalton proposed that every single atom of an element, such as gold, is the same as every other atom of that element. He also noted that the atoms of one element differ from atoms of all other elements. And today, we still know that this is the mostly true. Excuse me. A sodium atom is different from a carbon atom. Elements may share some similar boiling points, melting points, or even electronegativities, but no two elements have the same exact set of properties. Fourth is that atoms of different elements contains different mass. Lastly, atoms of different elements combine in fixed whole number ratios when forming compounds. Since atoms are indivisible, they will always combine in simple whole number ratios. Therefore, it would not make sense to write a formula such as 0.5 sodium and 0.5 chlorine, because you can have a half of an atom. So that's the end of my report. I hope you understand something. I hope something from this report of mine made your minds clear. And good day.
Hi everyone, my name is Jankin Linihan Villadares. So for now, we're going to discuss about the models of atom, which is the proton and the neutron. First, we will discuss what is proton. Proton is a stable subatomic particle occurring in all atomic nuclei with a positive electric charge equal in magnitude to that of an electric, but of opposite sign. So we're going to find protons. For example, Na to the power of 11. 11 is the atomic mass equals neutron equals protons equals electrons. So the Na is the symbols, the sodium is the elements. So the second one is the neutron. Neutral subatomic particle that is a continuum of every atomic nucleus except ordinary hydrogen. So we're going to find protons.
I'm Franklin Ito Kutungan. My discussion for today is about electron. What is an electron? An electron is the outermost early level of an atom. It helps from chemical bonds. For example of electrons. Electrons are the smallest of the particles that make up an atom, and they carry a negatively charged atom. The hydrogen atom, for example, has just one electron and one proton. The uranium atom has 92 electrons. Electrons, atoms excite in the physical shell to various radii representing energy level and largest the physical shell. The higher an energy contained in electrons. Thank you.
Hi everyone, I am Mark Tangara, and this time I will be discussing to you what is exactly an isotope. Isotopes are substances that are composed of the same elements but consist of different mass numbers and the number of neutrons. They share the same atomic number and therefore the same number of protons. For example, carbon-12 and carbon-13, these substances are isotopes of each other. Both of these atoms, they are carbon atoms. Now, the number you have seen here is the mass number. Carbon-12 has an atomic number of 6. The same is true for carbon-13. Atomic number of an element identifies the element, so carbon will always have an atomic number of 6. So in this example, both isotopes are elements of carbon, and if the elements are different, then you don't have an isotope. The atomic number tells us the number of protons. The mass number is the sum of the protons and neutrons. So both carbon-12 and carbon-13 have an atomic number of 6. Therefore, protons is 6. The number of electrons will be 6 as well. For a neutral atom, the number of protons and electrons are equal to each other. Now, the number of neutrons defined in subtract the mass number by the atomic number. So 12 minus 6 is 6. So carbon-12 has 6 neutrons and carbon-13 has 7 neutrons. Now let's look at another example. Let's say substances A and B. Now just because the two letters are different doesn't mean that elements are different. So A and B could represent the same element, or they could have represent different elements. So let us use numbers to figure out which is the case. So let's say substance A has an atomic number of 12 and the mass number of 29. And substance B has an atomic number of 12 and the mass number of 30. The question is, are they isotopes of chemicals? The answer is yes, because they share the same atomic number, which means that substances A and B are composed of the same type of element. However, the mass number is different, so therefore, the number of neutrons will be different, so substances A and B are isotopes of each other. Remember that isotopes, they have the same number of protons, same atomic number, and they are composed of the same element, but they have different mass numbers and different numbers of neutrons. And isotopes share the same chemical properties, but they differ in nucleus properties. The nucleus behaves differently because the number of neutrons is different, which exists in a nucleus. That is isotopes.